Hi folks. The next couple of lectures are going to be all about what we describe as solving triangles. And solving triangles simply means given a couple of pieces of the triangle, we need to find the remaining pieces. And one of the things we know that if a triangle is a right triangle, this is just very easy using standard trig. So it becomes a little bit more interesting when we try to solve a triangle that is not a right triangle. So let's begin by remembering the standard ways of proving two triangles congruent, the congruence theorems. And they are, in no particular order, side, 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 or angle, side, angle, excuse me, or angle, angle, side, a little sore throat, or side, angle, side. Now, what this means in the context of solving triangles means that if we're given any of these pieces of a triangle, it's always possible to find a unique triangle which satisfies those conditions. And that basically means to solve the triangle. Now, the law of sines is used when we have two of these conditions. The law of sines can be used when we have angle, side angle, or when we have angle, angle, side. So given those conditions, we'll be able to completely prove not prove, but we'll be able to solve a triangle, which is given either angle, side, angle, or angle, angle, side, we'll be able to find all of the remaining pieces. So first of all, let's make sure we write down what the law of sines is. I'm not going to prove this for you, but you will have seen this in your book. Your teacher will probably have proven it for you. And it's pretty easy to remember. So here is the law of sines. We either have sine of A over A equals the sine of B over B equals the sine of C over C. Okay? Or it could alternately be written as A over the sine of A equals B over the sine of B is equal to C over the sine of C. So these are equivalent. If we're looking to find an angle, we probably want to use one of these, and if we're looking to find a side, we probably want to use one of those. So let's look at an example in which we use the law of sines to solve a triangle. Sound good? So as we've said, one of the ways that we can solve a triangle is when we're given angle, side, angle. And this is a condition that allows us to use the law of sines. So let's consider that we have a triangle with the given pieces labeled. So this is the standard way to label a triangle. Here is vertex A, angle A, and the side opposite is labeled with the small a. Angle B, large letter, the side opposite, little b, and the same thing with the C's. So let's assume that we have this given information. Okay, so here's the information that you're given, and that corresponds to angle, side, angle. And let me fill in those pieces on the triangle. So once we're given two angles, we immediately can find the third angle because we know that the three angles in a triangle add up to 180. So now we know that the measure of angle C is 124 degrees. That's a large angle, and you should remember that the biggest side in the triangle is always going to be opposite the biggest angle. So C, which is 15, is going to be the biggest side. It better be. So now we'll simply write down the law of sines and enable us to find out what side A is. Okay, so I'll write that down and you can follow it. Okay, so here I'm using the piece of law of sines, which says that side A over the side sine of 36 is equal to 15, that's side C, over the sine of C, which we found to be 124 degrees. There we go. Okay, so if we solve this and we make sure that our mode of the calculator is in degrees, what we get is that A is equal to about 10.6. Okay, so now all we have is one side left, and that's side B, and so we'll simply write B over the sine of 20 is equal to 15 over the sine of 124. And if we solve this again using our calculator, we get that B is equal to about 6.2. And there we go. We have solved the triangle. Remember, that means we know all the angles and we know all the sides. So in red, we have the information that we were given, and in blue, we have the pieces of the triangle that we have found. And that's how we solve the triangle, using the law of sines. And remember, this was given, we were given here angle, side, angle. So let's look at a case in which we're given something else. And so here we'll be given the information angle, angle, side. Okay, so now we have a situation where we're given angle, angle, side, and let's draw a triangle and look at the information that we're given. Okay, so suppose we're given these conditions. We have angle, angle, side. So I'll label them in red. So given that information, we can immediately find angle A, because the angles have to add up to 180, and angle A turns out to be 100 degrees. So we'll put that in. Okay, and so now we'll use the law of sines to figure out what some of the missing pieces are. So I'll write down the following relationship. Okay, so check it out. We have side B over the sine of B equals C, which is what we're looking for, over the sine of C. And so if we solve that using our calculator, being nice and careful, what we'll find out is that C is equal to about 23.3. So you should check these calculations to make sure you can get them. And now to find, what are we missing? Side A, we do this relationship. So check that out and make sure that you can see where that comes from using the law of sines. And if we solve that correctly, we should get that A is equal to about 27.9. And so there we go. We've solved the problem. We've solved the triangle. There's angle A, there's side C, there's side A, and we're done. So in the next video, we'll look at the law of cosines, and the law of cosines helps us with side, angle, side, and side, side, side. See you then.